Okay, so here's another problem from section 2.7, our related rates. And this involves a cone. And it says we have water leaking out of an inverted conical tank. So there would be that cone. They tell us the rate at which it is leaking out. And notice our units are cubic units. So that tells us that we have a dV/dt equal to 10,000. And at the same time that water's leaking out, and so here's our water, and that's leaking out, there's water being pumped in at some other rate. The tank has a height of 6 meters. So that's from the top to the bottom. There's our 6 meters. It has a diameter of 4, which means it has a radius at the top of 2. And we got to be a little careful here because we have meters and centimeters there. And then the water level is rising at a rate of 20 centimeters per minute. And so that's our height, the water level. So dH/dt is 20 when the height of the water is 2 meters. So we've got to be careful with that. So that means that that would be 200 centimeters. Not m, but the height, which would be h. And it wants to know the rate at which water is being pumped into the tank. Okay, so we know that our volume equation is pi over 3 r squared h. And we want to know the rate at which water is being pumped in, so it's part of our dV/dt. And we have all this information about the water level, but no information really about the radius. But here's one of the things we do know. This relationship, the radius divided by the height, is going to be constant, is 2/6 or 1/3. So we know the radius is always going to be 1/3 the height anywhere along our cone. So if we make this substitution here, we get V equals pi over 3. So we have h over 3 squared, because that's what we're substituting for r, times h. Okay, that gives us pi over 27, now h cubed. So this significantly makes the derivative here much easier. So we have dV/dt, 3 times the pi over 27, which is pi over 9 h squared, times, because we're doing the chain rule, because h and v are both changing with respect to time, dH/dt. And we know that we are solving for this dV/dt. Well, dV/dt, technically, right, is going to be some number c that's being pumped in minus the 10,000 that is being pumped out. So over here, I'm going to have c minus 10,000 equals pi over 9. The height is 200, and dH/dt is 20. Okay, so I'm not going to do this math in my head. So we have 200 squared times 20. So that's 800,000. So we have c minus 10,000 is equal to 800,000 pi over 9. And if we add 10,000 to that, that will be the rate at which the water has to be entering the tank in order for the water level to be rising at 20 centimeters per minute at the moment that we are 2 meters or 200 centimeters high in terms of the water level. So a lot going on in that problem. A little bit tricky here with water being leaked out and pumped in at the same time. Hope this helps, and we'll see you soon. Oh, I forgot my units. My apologies. I just recognized that. So this would have to be cubic centimeters per minute, because we are a volume unit here.